have a situation like this where object 1 is going east and object 2 is going west with those corresponding velocities and masses, and then object 1 is a rebound, so it is going back at 80 meters per second going west, because the opposite of east is west. When you are saying rebound is or bouncing off is going in the opposite direction. This is a simple, or not simple, but typical 1D collision. So what we will do in this case, since something that is missing on the information before and after, what we will do is we will consider that this is an isolated system, which means that conservation law of momentum is true. To have a true conservation law of momentum means that the sum of momentum before is equal to the sum of momentum after the collision. Now, on the before, we have two objects. We have object 1, so momentum of object 1 and momentum of object 2 is equal to, even after the collision, the two objects are collided heads on, and then one is going on the opposite direction, and we don't know what is happening with the second one. So we still have two objects, so P1 prime plus P2 prime. As we see here, this is a 1D collision. Why is it 1D collision? Because everything is happening along east-west axis. So therefore is 1D collision. When we have 1D collision and we are working with vectors, we assign a positive direction. What do you think that the positive direction would be? Would be east or west? You can choose any. You can choose any that you want. However, we will consider on this case that going east is a positive direction. Even if you choose west, you should have the same result. And then as the second step will be, we will add and with positive and negative numbers. So momentum 1, 1.50, that is the mass, times 12.0, that is the velocity, will be 18.0 kilograms meters per second going east. So I will write it here. P1 is 18 kilograms meters per second going east. Is this 18 a positive or a negative value? Since it is going east, and our positive direction is going east. Is a positive value. Plus, because this is what we have from the adding the two vectors. Now, 2.50, that is the mass of object 2, times 10, that is the velocity of object 2, will be 25. So P2 will be 25.0 kilograms meters per second going west. What is going west, the 25.0? Is it positive or is it negative? It is negative since it is going west. Is equal to, and now let's move to the after collision. So we have the object 1 is moving at 8.00 meters per second going east, which means that we will have a momentum of 1.50 times 8.0. So momentum of object 1 after the collision will be 12.0 kilograms meters per second going west. So now this momentum, since it is going west, is it positive or is it negative? it is negative. So negative 12.0 plus, why plus? Because this is what we have here. This is what the relationship dictates us, plus x. You can leave it as P2 prime, or you can leave it as x. You can assign it with another variable. It is fine, whatever you do. And then, now see what do you have? You have a equation with one variable. And this is the whole thing. Everything that we do in science is we try to write it into an equation with one variable or two variables with two equations. So now we will solve for P2 prime. So P2 prime will give us, as a after collecting like terms and adding and subtracting everything that it needs to be, it's 5 kilograms meters per second. It's positive. The fact that it's positive means that it is going in which direction, east or west? .0 kilograms meters per second going east, because this is what we assign to be the positive direction. However, we are not looking for the momentum of object 2 after the collision. We are looking for the velocity of object 2 after the collision. So momentum and velocity have the same direction. Velocity of object 2 after the collision will be whatever is momentum, meters per second going east, divided by the mass of object 2, which is 2.50 kilograms. And see now, kilograms and kilograms are cancelled out. And the velocity of object 2 after the collision will be 2.0 meters per second going east. If they are asking for the momentum, then you will state momentum as 5.0 kilograms meters per second going east. If they're asking for the velocity, then you will state that it's 2.0 meters per second going east. Okay, so now we will see an example in which we'll start with an object that is at rest, and then it is broken either in 2 or 3 pieces. When it is in 2 pieces, is considered to be a 1D. When it is in 3 pieces, is considered to be a 2D. We'll do both cases. So the first example is when we have one object with mass of 3.80 kilogram and is at rest, which means that the velocity of the object is equal to 0. And then this is, let's say that this is a bomb, this is explosion. And then after the explosion, what do you notice is that one object with mass, so part 1, let's say, mass 1 prime, is with 1.20 kilogram. It is moving with a velocity of, let's say, 12.8 meters per second going east. Where are we expecting that the velocity or object 2 will be? Okay, so you have an object 2 here, or part 2 of the object that is moving on the other direction. Before we go ahead and then solve this and see what math will tell us, in which direction are you expecting that velocity of object 2 will be? In east or west direction? So yes, it is correct. Will be on the west direction, what you are expecting it to be. However, you don't even have to think about it. Math will tell you that it is in west direction. So let's see now. Again, since something is missing, then we will assume that we are dealing with isolated system when the conservation law of momentum is true. Being true as the conservation law of momentum is telling us that the sum of momentum before is equal to the sum of momentum after the collision. Before the collision, we have one object that is at rest. What is momentum of an object that is at rest? It's zero, because anything, whatever is the mass multiplied by zero, that is the velocity at rest, will be equals to zero. And this will be equal to, now we have two pieces, two parts. One of it is going in the east, and one that we don't know, or quote unquote, we don't know where is it going. This situation is a 1D situation. And since it is 1D, what we do is we assign a positive direction. And again, I will assign the positive going in the east. And we add with positive and negative numbers. Now, the mass 1.20 of the first part multiplied by 12.8, the velocity of the third part will be momentum of the first piece is equal to 153.6 kilograms meters per second going on the east direction. And we don't know what is momentum of second part of it. Anyway, since it is 1D, we will applying the conservation law of momentum will be 0 is equal to 153.6 going east. Since the positive direction is going east, is it positive or is it negative? By the way, it's not 100, but it is 15.36. So is it positive 15.36 going east or negative? It's positive 15.36. And we don't know what is the momentum of the second piece after the explosion. Therefore, we assign it with either X or we leave it as P2 prime. So from here, we can find that P2 prime is negative 15.36 kilograms meters per second. And what negative means that is opposite of the positive. So this is the same as saying is 15.36 kilograms meters per second going, the opposite of east is west. However, we are not looking for the momentum of the second piece. We are looking for the velocity of the second piece. So in order to find the velocity, we divide the magnitude of momentum, 15.36, by the mass of the second object. How are we going to find the mass of the second piece? Using the fact that we have a mass conserved, because in an isolated system, the energy is exchanged, but mass is not. So mass of second piece will be the total mass as 3.80 minus the mass of the first piece, 1.20. So 3.80 minus 1.20 will be equals to 2.60 kilograms, which means that the velocity of the second piece after the explosion will be 15.36 kilograms meters per second going west, divided by 2.60 kilograms, which means that kilograms and kilograms are canceled out. and you will have a velocity of 5.91 meters per second going west. So example 5 will be an explosion when now instead of 2 pieces, we'll have 3 pieces. So let's suppose that we have an object with mass of 6.80 kilograms before the explosion, and then it is at rest, which means that velocity is equal to 0. And now what we have is we will see 3 pieces. So part 1, part 2 will be something like this, and part 3. Mass 1 is, let's say, 1.40 kilograms, and it is moving with a velocity of 12.3 meters per second, not kilogram, at 35 degrees north of east. So it is moving like this, V1 prime at 35 degrees. Piece 2 is with mass of, let's say, 2.50 kilograms, and it is moving with a velocity of 8.57 meters per second at 50 degrees north of west. So will be a velocity that is like this, and the angle with west will be 50 degrees. And we don't know what is happening with the third one. So V3 prime is question mark. Since we are here, let's find the mass of the third piece, because we are considering that we are dealing with the isolated system, which is telling us that the mass will be conserved while the energy may be exchanged. So mass 3 will be 6.8 minus 1.4 minus 2.5 will be equals to 2.90 kilograms. Okay, so is this a 1D or 2D situation? Okay, so this is a 2D situation because we see an angle formed with even one, then will be considered 2D. With northeast southwest axis is 35 and 50, so then it's a 2D situation. Momentum before is equal to momentum after. Momentum before is equal to 0, since it is mass times anything multiplied by 0 will be equal to 0. And a momentum after will be now with 3 pieces. So part 1, or piece 1, piece 2, and piece 3. Now we don't need to build 2 tables here because the B4 is equal to 0. We just build one table of components. So the after, horizontal and vertical, and then we have P1 prime, P2 prime, P3 prime, and then the sum of them, which is equal to the sum of momentum before. And the sum of momentum before was equal to 0. And a 0 vector has a 0 horizontal and a 0 vertical component. So now momentum 1 will be 1.40 times 12.3, and it is 17.22. So I will just draw it here. 17.22 at 35 degrees north of east. And for the second piece, we will have 2.5 times 8.57 and will be 21. So if this is P1 prime, then P2 prime will be 21 point, let's say 43 at 50 degrees, 50, not 30, 50 degrees north of west. So what is the horizontal component of P1 prime? Will be 17.22 times. Horizontal, since it is adjacent, will be cosine 35. And it is positive, so will be 14.11. And then the vertical component, since it is the opposite, will be 17.22 times sine and will be positive 9.88. For the second piece, the horizontal will be again cosine, so 21.43 times cosine 50 and will be 13.77. But since it is going west, will be negative, so negative 13.77. And the vertical component will be positive, since it is going north, and will be 21.43 times sine 50. And it is positive 16.42. We don't know what is the momentum of the third piece. Therefore, we assign it with a variable. Now, what do we have from the horizontal component? Is positive 14.11 minus 13.77 plus x is equal to 0. And from the vertical, we have positive 9.88 plus 16.42 plus y is equal to 0. So we can solve for x and y. So solving it will be x is negative 0.34. And if we want to state the units, will be kilograms meters per second. And y will be negative 26.3. Again, it is momentum, so will be negative 26.3 kilograms meters per second, which means that in terms of, now we are composing the vector, we have a negative vectorially, negative 0.34 and negative 26.3. which tells us that the third piece will have a momentum that look like this. The magnitude of this momentum will be the square root of 0.34 squared plus 26.3 squared equals to 26.3 kilograms meters per second. And angle theta with the horizontal will be inverse tangent of opposite, that is 26.3 over adjacent, that is 0.34. 89.3 degrees. And if you are stating the momentum of the third piece, is 26.3 kilograms meters per second at 89.3 degrees, and this will be south of west. But the question is asking you for the velocity, so you will divide the magnitude of momentum by the mass of the third piece. And the mass of the third piece is 2.9, so velocity of the third piece will be 26.3 kilograms meters per second, divided by 2.90 at 89.3 degrees south of west. And 26.3 divided by 2.9 will be 9.07. So velocity of the third piece will be 9.07 meters per second at 89.3 degrees south of west. This is what you have to state for velocity, and if they're asking for momentum, you have momentum as well. We can round it to, yes, we can round it, it's fine. We can round it even to 9.10, it's fine. But this will be how you will solve a question in an explosion.